Even today, I go straight to the point without any weird introduction. Today we are going to address a very wide topic that is all about the slip, or the so-called barbottina. More precisely, we will talk about the rheology values of these semi-finished products, trying to identify the most important elements that may affect them, also pointing out the milestones that must be considered to avoid sudden and unpleasant change that may negatively impact on the production process. So, let's start. I am Davide Trentini, and this is Apparently Invisible, Chemistry in Ceramics. Let's start, as usual, with a short introduction and a statement that in this case may seem obvious, even if it's better not to take anything for granted. Generally speaking, wet grinding systems and as well as atomization systems offer best performances and best production results only when chemical and physical features of the slip are and remain, we could say, constant over the duration of the entire process. We could also say that, more precisely, we achieve the best conditions only when the main parameters of the atomized products, and so we are talking about grain size, density, viscosity, and thixotropy, remain over time within a very short range. And in theory, grinding mills are able to produce almost identical slurries only when the production conditions do not change. In this case, I'm referring to raw materials, formulas of ceramic mixtures, process water, milling times, etc., etc., etc. I said in theory because since there are many variables, slurries may suddenly and often change their rheological features during production, sometimes drastically. The change can be different and various, and so, just to make things easier, we address only the two main scenarios, that is, excessive or very low viscosity values. Let's try to understand together what we are talking about. An extremely high viscosity value, especially when it comes with high levels of thixotropy and flow limit, can cause different kinds of problems. The most common and significant can lead to improper grinding process, long discharging times of the mill, sometimes even incomplete, improper sieving, jelly phenomena in the tanks, clogging of the pumps that may produce a partial or complete block of the production plant. So this is more or less what may happen in case of too viscous slips. But what happens instead if the slip is marked by a very low viscosity? A very low viscosity value can similarly lead to poor milling results and so to a high residual content, or it can produce high consumption of the grinding tools, as well as a sedimentation phenomena of the solid matter within the tanks, whose removal, as you can imagine, may be a little bit complicated. Anyway, given these two macro scenarios, let's try now to list what are, or even what may be, the main elements that can affect, positively or negatively, the proper rheology of a barbottina. Before doing this, I just want to inform you that in this case, differently than usual, I give you only a list with some examples, of course, but without the conventional approach based on problem and solution. The episode is more like, be aware. That said, the values of slip may be affected by many elements and the list may be long, very long. So here is, with the help of our bell, the most representative. Primary raw materials, secondary raw materials, grinding water, the flocculants, grain size, temperatures, grinding bodies. Good. After this introduction, let's now see in details each item on the list starting from the primary raw materials. Even if they are carefully chosen, raw materials, and especially clays, are natural products and for their very nature can undergo to variations that cannot always be controlled, especially if we consider that the stocks are constantly and frequently restored. Just to make an example, the change in the level of plasticity that, as we know, also affects the mechanical resistance of the raw ties may promote significant variations of the rheological features of ceramic mixtures. Fluctuations of the humidity may similarly modify the viscosity values, affecting at the same time the density values. In extreme cases, in the event of modifications of the chemical and or mineralogical composition of the raw materials, it would be hard to trace and define the causes of the rheological modification by means of chemicals or X-ray analysis. In fact, in some cases, even these strategies are not able to give you back rigorous answers. Regarding secondary raw materials, and here is the second item of our list, we can say that sometimes even the addition or variation of the chemicals involved within the slurries, both organic and inorganic, can lead to variation in the rheological behavior. We are basically saying that even chemicals are definitely necessary for the proper development of the process. Their use, regardless of they are binders or plasticizers, should always be preceded by rigorous analysis within the lab. And the same applies to variations or additions of sledges, glazes, or recovered materials deriving from other production departments. Even these materials, in fact, should be always and previously checked to prevent a possible negative impact on the rheology values of the slip. And now, let's address grinding waters. Before starting, I just want to remind you that about this topic, and more precisely about process waters, you can find an entire episode, the episode number 4, within which we took a closer look at a lot of bad consequences that may arise if process waters are not properly managed. So you can go back there to have a wider idea, because now we offer you just a short mention to those process waters involved in slips production. So, the contents or ingredients of grinding waters are usually difficult to define. The current trend, in fact, is to recover inside the grinding waters the wastes produced within the company, also adding, in some cases, the waste of other and external producers. This offers a reasonable help to the environmental problems, of course, but at the same time, it can negatively affect the rheology of the slurry, sometimes promoting flocculation phenomena. In this regard, many and different studies have shown that very high conductivity values of flocculating metal ions, organic matters, and acid pH may significantly worsen the viscosity and flow limit of the barbottina. And regardless of the consequences, the most important clinical issue is about the extreme variability of the waters involved in the milling process. And this is the reason why it should be important to take some essential preventive action. What action are we talking about? First of all, it would be better to stock the waters in large tanks to reduce the range of the fluctuations. Then, it is important also to check the density of the waters, their dry content, so that out of standards value do not affect the density of the slip. It would be also great to check the pH value and the electrical conductivity of the water, adjusting the parameters when necessary. A too acid pH, for example, may worsen the viscosity and the flow of the barbottina. Another important action is about the careful analysis of the water deriving from the purifiers. Then, even if they apparently seem clear and clean, they can hide pitfalls, such as important amount of flocculants, for example. And finally, it may seem trivial, but instead it is fundamental to check up and properly manage the possible presence of bacterial contaminations that can increase the water's electrical conductivity. That, as we know, it is never good. That said, let's address now the fourth item of our list, an item that closely concerns us since it involves a specific category of chemicals, that is, flocculants. We should talk about them for a long time, but we will just say that the proper rheology of a slip may also be affected, as you can imagine, by a wrong dosage of the flocculants. Each of them, according to the application conditions, is in fact marked by specific features that differently impact on the rheological values, such as, for example, the viscosity. The rate of each flocculant also changes according to its specific features. And this is the reason why, even if the addition within the slip is usually developed by means of electromechanical systems, it is recommended to periodically check the quantity in use, so to avoid problems that in extreme cases may force producers to properly adjust the process. And then we have the grain size, the fifth item of our list. Yes, because even the grain size may affect the rheological features of a slip. And so the question is, how? To put it simple, we can say that all other things being equal, and I repeat it, all other things being equal, a high amount of residual matter stands for low viscosity values, and vice versa, a low amount stands for high or very high viscosity values. What does that mean?
The sieving process is usually developed by means of dense mesh screen. So the presence of high amount of residual matter means that the grinding process has produced a barbottina or a slip marked by a coarse particle size that in turn results in a greater flow and in lower viscosity values. On the other side, when the milling process produces a smaller grain size, particles are marked by a lower wettability, and this means that we are facing higher viscosity values, in general, of course. This simple statement is telling us, just as an example, that when viscosity values are really too high, there is no point to keep on milling without taking previously other actions. Similarly, the temperature of the slip during the grinding process, of course, is another aspect that must be carefully considered, since it may affect the proper dispersion of the suspended particles. The temperatures, in fact, influence the deflocculant's efficiency during the grinding and dispersing processes, affecting therefore the rheological parameters of the suspension. In general, we can say that high temperatures promote a better grinding process, and vice versa, too high or too low temperatures may decrease the production yield. And finally, before saying goodbye, we end with a brief reference to the number and the grain size of the grinding bodies that, of course, not only affect the proper conditions of the mill, but that are also the basis of a proper grinding process. Checking and adjusting these parameters is surely useful, if not necessary. However, we have to admit that even a little attention does not usually promote sudden changes in the rheology values of the slip. It can only lead, over time, to worsening the trend of the milling process.
And with this last suggestion, that actually is not so important but that is better to take into account, even today we have come to an end. As usual, I remind you that you can listen to the previous episodes on the main platform, such as Spotify, Google Podcasts, and Apple Podcasts, or on our app that you can download for free on Apple Store or Google Play by typing Z&S Ceramco, Ceramco, or Apparently Invisible. See you soon in a couple of weeks.